Hello students, welcome to AIMS India online classes. This is a chemistry session. Here we are discussing about water. In the earlier session we have seen the importance of water, how it is useful for the living things, and the different states of water we have seen in the earlier session. Now let us see the sources of this water, from where we are able to get this water. Okay, those are called sources of water. Before that, let us say about the interchangeability of states of water. Means we said water exists in three different states. What are those? Solid, liquid, as well as gaseous state. In the solid state, water is available in the form of ice. At normal temperatures, water exists in the liquid state. At higher temperatures, water exists in the gaseous state, which we call as water vapor. But here, these three states of water are interchangeable. Means one state of water can be converted into another state and can be reversed that process by changing temperature. That we say as interchangeability of states of water. Water can be converted from one state to another state and then brought back to the original state by changing the temperature. Liquid water can be changed into solid state, that is into ice state, by cooling it to 0 degrees Celsius state temperature, because water exists in the solid state below 0 degrees Celsius. So if you take normal water, liquid water, and if you cool that by keeping the refrigerator and so by decreasing its temperature below 0 degrees Celsius, then water converts into solid form that we call as ice. Similarly, water can be changed into water vapor by heating it to 100 degrees and above, because water exists in the gaseous state above 100 degrees Celsius temperature. So if we take normal water and if we start heating it, after reaching 100 degrees Celsius temperature, it converts into gaseous form, which we call as water vapor. In this way, the states of water can be changed from one to another by changing temperature. Here, the process of converting liquid water to ice is called freezing, and the reverse process, that is conversion of solid ice into liquid water, is called melting. Both freezing of water and melting of ice takes place at the same temperature. Okay, we know the process of converting liquid water into ice is called freezing. In the reverse way, the conversion of solid ice into liquid water is called melting. These two processes, that is melting and freezing, these two occur at the same temperature. The constant temperature at which water changes from liquid state to solid state upon cooling is called freezing point. Okay, the temperature at which liquid water changes into solid state ice is called freezing point. In the reverse way, the constant temperature at which water changes from solid state to liquid state upon heating is called its a melting point. So actually, melting point and the freezing point are of the same. For example, for water, the freezing and melting points of pure water are at 0 degrees Celsius temperature. That means if we take water, if we cool water to 0 degrees Celsius temperature, then it starts converting into solid ice form. So this 0 degrees Celsius temperature is called a freezing point. In the reverse way, if we take ice cubes which are having temperature below 0 degrees Celsius, if you take them out from the refrigerator, then they start absorbing temperature, means they are being heated up. So if their temperature reaches 0 degrees Celsius, then ice starts converting into liquid water form. That process is called melting, and the temperature at which ice converting into liquid water is called melting point. That is why we told here the freezing point of water and the melting point of ice both are one and same, that is equal to 0 degrees Celsius temperature. Okay, and small quantity of water keeps changing into vapor at all temperatures, isn't it? So need not to heat anything there. At normal temperatures also, small quantity of water from water bodies like lakes, rivers, ponds, and from this all, from the surface of these water bodies, small quantity of water will become converting into vapor form. This process of conversion of liquid water into vapor is called evaporation or vaporization. Okay, by this process, small quantity of water will be always converting into gaseous form. That process is called evaporation, which is also known as vaporization. Okay, this is why our perspiration dries up. We often get sweat. After certain time, that vapor, that sweat will be dried up because of this evaporation of that water came out from the body. Okay, and this is occurring at room temperature only, isn't it? So at room temperature also, small quantities of water will be converting into gaseous form, that is vapor form. That process is called evaporation. So this is the reason for wet cloths drying up even in the shade also. Have you observed this? Often we hang these wet cloths even in the shade also. Even when they kept in the shade also, they'll be dried up after certain time. This is because the water present in the cloths slowly it will evaporate off. That's why the clothes become dry. However, if we heat water, it starts boiling at 100 degrees Celsius temperature and rapidly changes into steam. So at normal temperature, small quantity of water converts into gaseous form that we call as evaporation. But we start heating water till 100 degrees Celsius. So after reaching 100 degrees Celsius temperature, it rapidly changes into steam form. That process is called boiling. So boiling and evaporation is a slight difference. Evaporation occurs at all temperatures. Even at very low temperatures also, small quantity of water converting into gaseous form. That we say as evaporation. Evaporation occurs at normal temperatures also. But when we heat water, if it reaches 100 degrees Celsius temperature, then it starts converting into steam very rapidly. That temperature at which liquid water converting into steam is called boiling point, and that process is called boiling. Now if we cool this steam obtained, it changes into liquid water at 100 degrees Celsius again. So if we cool that steam obtained there to lower temperatures, after reaching again 100 degrees Celsius temperature, it converts back into liquid water form. So here the constant temperature at which water changes from liquid state to gaseous state on heating is called boiling point. Okay, the temperature at which water changes from liquid state to gaseous state is called boiling point. On the reverse way, the temperature at which the gaseous state of water converts into liquid state upon cooling is called condensation point. Okay, just like the freezing and melting, these two are also reverse processes and these two also occur at the same temperature. The conversion of liquid water into gas is called boiling on heating, and the conversion of gaseous steam or vapor into liquid water on cooling is called condensation. The temperature at which a liquid converts into gas is called boiling point, and the temperature at which a gaseous state converts into liquid state water is called condensation point. So boiling point and condensation point both are one and same, but in the reverse way. Okay, the boiling point of pure water is 100 degrees Celsius temperature. That means on heating water to 100 degrees Celsius temperature, it starts converting into steam or gaseous form. That is called boiling point of water. In the reverse way, if you cool the steam to 100 degrees Celsius temperature, it starts converting into liquid water. So the condensation point of water is also 100 degrees Celsius. Okay, these two occur at the same temperature. Condensation and boiling both occur at 100 degrees Celsius temperature only. So these are different conversions of water from one state to another state. These we say as interconversions of states of water. If you see solid ice, this on heating it converts into liquid state water. That process we call as melting. This melting occurs at 0 degrees Celsius. So actually ice will be below 0 degrees Celsius temperature. So if you heat this after reaching 0 degrees Celsius temperature, it converts into liquid water. That process we call as melting. If you heat this water continuously after reaching 100 degrees Celsius temperature, it starts converting into steam or water vapor. That process we call as boiling. This boiling of water into water vapor occurs at 100 degrees Celsius temperature. So that we call as boiling point of water. In the reverse way, if you cool this water vapor or steam to 100 degrees Celsius, it converts into liquid water again. That process we call as condensation. So this also occurs at 100 degrees Celsius. So we say the condensation point of water vapor is also 100 degrees. So if you cool this water again further low temperatures, after reaching 100 degrees, 0 degrees Celsius temperature, this water starts converting into solid ice form. So that process is called freezing, and the freezing point of water is also 0 degrees Celsius. Okay, they are the interconversions of states of water. These all occur by changing the temperature. Okay, now let us see the sources of water, means from where we get this water. The largest amount of water on the Earth's surface is in the form of oceans and seas. The oceans and seas cover more than two-thirds surface of the Earth, isn't it? The seawater is salty and cannot be used at home and even in agriculture also. Even though large amount of water is present in the oceans and seas, it cannot be used for our purposes like consumption, and for domestic purposes we cannot use this seawater. We cannot use this water for even for agricultural purpose also, because seawater contains large amounts of salts dissolved in it. So seawater is being salty. That's why we cannot use this water for our daily purposes. So the sources of natural water can be divided into two groups. They are surface water and underground water. There are two major sources of water for us. One it is surface water, another one is underground water. Let us see about this one by one. First, let us see about surface water. The water present on the surface of the earth is called surface water. There are three main sources for this surface water. Okay, if the water is present on the surface of the earth, then it is called surface water. Example, rivers, lakes, oceans, ponds, seas. In these all, water is present on the surface of the earth. So we can call these all as the surface water. So these all can be categorized into three types. So the surface waters are of three types. They are sea water, next river or lake water, another one is rainwater. These all waters are present on the surface of the earth. So this we say as surface water. Okay. First, if you see about sea water, when the rivers discharge in the sea, most of the suspended impurities present in it are deposited at the river mouth, resulting in the formation of delta. Okay. So all the water from the lakes, rivers and these all finally reach oceans and seas. So large quantity of water is present in the seawater. The dissolved mineral salts are, however, carried into the sea. From the rivers and lakes, the water carries so many minerals and salts into sea. So seawater is the most impure natural water we can say, as far as the dissolved impurities are concerned. Because large quantities of minerals and salts are carried by these rivers and lakes. Finally, they reach the seawater. That's why we say seawater is the most impure form of water, which dissolve many minerals and salts into it. Okay. On an average, 1 liter of seawater contains around 26 grams of dissolved salts in it. The chief amongst them is common salt, which we say as sodium chloride, which on an average it is present in 24 grams per liter. So if you take 1 liter of water from the ocean, it contains around 24 grams of common salt. Remaining 2 grams will be other salts. So remainder consists of mainly salts of calcium and magnesium. Okay. Mostly present salt is common salt, which we say as table salt, or chemically it is called sodium chloride. This is the salt which we use at our domestic purposes. In cooking, we use this salt, common salt, isn't it? So, as a matter of fact, seawater contains traces of almost all metallic salts, not only sodium salt, calcium and magnesium salts. Almost all metallic salts are present in seawater. This includes that of gold also. So we can say almost all metallic salts are present in the seawater, but in traces. Largely existing salt is sodium salt, that is a sodium chloride. Okay. Next, river water. One of the surface water forms is river water or lake water. A river is a long stream of water running through a definite course of land. River water falling, rainwater falling on the hills comes down as rivers. So the rain occurring on the mountains and rivers, hills, this slowly comes in the form of streams and forms a river. Melted snow from the mountains flows down the slopes and joins the rivers. From the polar regions and ice caps, the melted snow slowly reaches the rivers. So rivers ultimately flow into oceans. As the water flow along the surface of the earth, it collects different kinds of impurities into it. Thus, river water contains a large amount of dissolved minerals like calcium, etc., and suspended impurities such as clay. So, as these rivers flow from one place to another place, while flowing, they dissolve many impurities from the place to place. So, they contain different minerals and even clay particles also in them. So, we can say it is also impure form of water. Next, rainwater. Actually, rainwater is the purest form of naturally occurring free water. It is because it is formed by the natural distillation of surface water or seawater by the heat of sun. So it is rainwater is formed by the natural distillation, isn't it? What is meant by distillation here? Distillation includes two processes: evaporation and condensation. So when we heat a liquid, it converts into gaseous vapor. If we cool those vapors, they convert back into liquid by the process called condensation. So these two processes together collectively called distillation. So rainwater is formed by the natural distillation of surface water. What happens by the heat of sun, water from the water bodies like oceans and rivers, it converts into vapor. It evaporates. So while evaporating, it won't take any impurities with it. Only pure water molecules will go into the atmosphere and converts into vapor. Again, when they reach the cooler places, they convert back into water droplets by the process called condensation. So that comes down in the form of rain later. So that rainwater is we can say as purest forms of water, one of the purest forms of water. Rainwater is a naturally occurring pure form of water. Rainwater does, however, contains some impurities. As raindrops travel through air, they do pick up dust particles floating in the air. So actually we say when it is starts, rainwater is the purest form. But while in the journey, while it reaching the earth surface in its path, it dissolves certain dust particles present in the air. At the same time, they also dissolve a little oxygen and nitrogen and a fair amount of carbon dioxide gas. Small quantities of oxygen and nitrogen gas will be dissolved into the rainwater while coming down. And a fair amount of carbon dioxide gas also will be dissolved because carbon dioxide is fairly soluble into water. It dissolves large quantity. So the carbon dioxide dissolves into water, rainwater to form a weak acid which we commonly call as carbonic acid. This is the acid present in the soft drinks which we drink often. Soda and soft drinks, these all contain this carbonic acid. This is formed by the dissolution of carbon dioxide gas into the water. So this happens naturally also. When droplets of rain, when they coming down in their path, they dissolve this carbon dioxide gas present in the air and they form this weak acid called carbonic acid. Okay. Now let us see the another source of water, that is underground water. The water which percolates through the upper layers of the earth's surface and is collected on the solid rocks under the ground is called underground water. This underground water also contains two major sources. So the main sources of underground water are well water and spring water. These two are the major sources of underground water. What are those? Well water and spring water. So this spring water or well water, it is obtained from these sources is not always fit for drinking. That is, water obtained from wells or spring water is always not fit for drinking and even for cooking purpose also because many impurities and germs may be present in it. Various methods are used to make it fit for drinking. If we dig deep enough, we can generally reach this underground pool, which is commonly called as well water or spring water. Here, the level of groundwater below the surface of earth at a given place is known as water table. So to collect this spring water or well water, we have to dig the surface of the earth till reaching this water table. The level of this groundwater under the layers of the earth is called water table. Okay, this underground water can be collected by digging wells or bore wells. Nowadays, in the olden days, they used to dig wells to collect this groundwater. But nowadays, what we are doing, we are drilling the surface till the water table by using machines. We call those as bore wells. We are able to collect this water through the motor pumps, isn't it? This is about groundwater. Okay. Thank you for watching our video. Please subscribe our YouTube channel Aims Today for latest updates on recorded videos.